All right, welcome to the last problem, number 5 of page 4. Okay, hopefully you've already gone through all the other problems on all the other pages, or most of them, before attempting this problem. Okay, because a lot of my explanations are going to require that you understand and can kind of follow along at a faster pace, for which I will explain this problem compared to the other problems I've already done. Okay, first things first, you always list what's the given amount of given information. I have 200 grams of C2H6, nothing else. I don't have any other gram value or anything else numerically. That's what I'm going to start with. 200.0 grams of C2H6. That's where I begin my calculations. Where I want to end up, and what I want, is the mass of CO2 that will form. So I'm going to write equals, and the unit of mass is grams of CO2. Okay? I left a blank space there for the numerical answer that I will achieve, and I left a big blank space here for the calculations I'm going to do. Okay? All right. So the key to understanding this is I need to essentially go from C2H6 to CO2. What's their relationship? You will find that relationship in the chemical equation given above. Okay? A balanced equation, right? Okay, so how you're supposed to read this chemical reaction or equation is like this. Every 2 moles, by the way, everything's in moles. For every 2 moles of this chemical, C2H6 chemical or molecule, if you add that to 7 moles of O2, 7 moles of O2 chemical, if you add 2 moles of C2H6 chemical plus 7 moles of O2 chemical or molecule, you will create 4 moles of CO2 chemical, as well as 6 moles of H2O chemical or molecule. Okay? So the relationship, though, is only between the two people we're interested in, C2H6 and just CO2. Look how they're related. For every 2 moles of C2H6, I know I could produce 4 moles of CO2. Don't worry about the other guys, O2 and H2O. It's only these two we're concerned about. So again, the ratio, okay, a relationship is for every 2 moles of C2H6, I will definitely form 4 moles of CO2 in this relationship, okay? 2 to 4. Let's say, for instance, though, I had 4 moles of C2H6. How many moles of CO2 would I make? If I know that for every 2 moles of C2H6, I will produce 4 moles of CO2. So if I had twice the amount, if I had 4 moles of CO2, C2H6, that means by this ratio, 2 to 4, if I had 4 moles of C2H6 instead, I would then create twice the amount that I see here, which would be 8 moles of CO2. Could you follow that? Rewind if you need to hear me out again. But if you could follow that logic, hopefully you understand that this needs to be converted to moles of C2H6. I want to see how many moles of C2H6 I have here in order to kind of look at the relationship and kind of figure out how much CO2 I actually got in moles, okay? I know I want grams of CO2, but we're not there yet, okay? Okay, so first things first, I need to know how much this translates to into moles of C2H6. I have it in grams. So you know what I need? I need to know how much just one mole of C2H6 weighs in grams. That's called the molar mass of C2H6. I need to know that. Whatever the molar mass is, I'm going to do some computation with this value. Okay. Oh, I see molar mass, but unfortunately, it's molar mass of CO2 that's conveniently given to you. So guess what? We're going to have to construct it on our own. We need the help of a periodic table, which I have right here. Okay, I have a tab open for periodic table. I like using ptable.com, the letter P. I don't know if you guys can see that. Oh, come on, come on. Uh-oh, I'm frozen here. Okay. ptable.com. Okay, so let's go back again really quick. It's C2H6, carbon and hydrogen. Let's find carbon, because I won't find C2H6 on the periodic table, but I can find the individual components like carbon, that's 12, Let me make a note of that to myself on a separate sheet of paper. I'm sorry, you're going to have to do this too. Carbon is, I'm going to round that value. It's at 12.011, but I'm just going to round that to 12 grams. That's how much 1 mole of carbon weighs, by the way, in case you didn't know. That value represents how much 1 mole of carbon, how much it weighs in grams. And the other guy that I need to look at is the hydrogen involved. Let's hover over hydrogen. Hydrogen is 1.008. I'm going to round that to about 1. Okay? So over here, I'm going to write H is 1 gram. So every 1 mole of hydrogen weighs 1 gram. But let's take a look at the chemical formula. It's C2H6. I'm trying to find the molar mass of C2H6. So what I'm going to do is I'm going to multiply that, the C, the 12 grams, by 2, because there's 2 carbons. And the hydrogen, since there's 6 of them, I'm going to multiply that 1 gram by 6. So I have 24 grams and 6 grams. Let's add that together to get the molar mass of C2H6. 24 plus 6 is 30 grams. Or 1 mole of C2H6 weighs 30 grams of C2H6. Okay, let's just be redundant. Okay, so what I just solved for is the molar mass of C2H6. I can multiply this to this. But hold on. I have to look at the alternate way I could write this ratio, this conversion factor, this fact. I could also say that instead of 1 mole of C2H6 on the bottom of this fraction, I could also write it in a way where it's on the top. 1 mole of C2H6 on the top, and on the bottom, instead of having the 30 grams of C2H6 on the top here, it'll go on the bottom in this version. So the question is, which version am I going to multiply this by? Think about it. I'm going to pick this version. I didn't just randomly pick it. This is the version you have to use to get the right calculation. So let's go ahead and write this in to here to multiply this to. I'm going to multiply this by, put it on the side there, this version, 30 grams of C2H6 on the bottom and 1 mole of C2H6 on the top. Now, why did I choose that version? Okay, hopefully you watched some of my previous videos and problems by now. So when I explain this a little faster, you'll understand what I mean by this. I wrote it in a way where the units of grams of C2H6 will cancel out. I want to go from this unit ultimately all the way to the end to grams of CO2. But along the way, for every calculation, I want to delete the units I'm currently in to a new unit, to moles of C2H6. Mathematically, the reason why I can do that, it's this argument can be explained by something like this example. 7 times 13 divided by 7. In case you did not know, this whole number times this fraction, because these numbers, this whole number resembles this number in this fraction on the bottom, they end up canceling each other out. Why? Because if I multiply this out, 7 times 13, and I have 7 on the bottom, look, they have a number on the top and the bottom that is the same. They cancel each other out, okay? This and this mean the same thing, but this way looks more like what's happening here. We can apply this logic to the units. Grams of C2H6 times this ratio, where the units is grams of C2H6 on the bottom. When I multiply these two values, this and this fraction value, the units will cancel out because of the location of the grams of C2H6, okay? Okay, I'm going to erase this so I can just make this clean. I can keep this workspace clean for us to continue so you're not confused by everything that's in this video, all right? Or what's in front of you in the screen, I mean. Okay. By the way, let's just see. If I multiply this out, what would it be? If I mean, this isn't the final answer, but let's just see what we would have. 200.0 times 1 divided by 30. I can put that all in one entry in the calculator. I got 6.66667. Okay, what does that mean? That means I have 6.66667 moles of C2H6. That's the last unit, so this is what the answer would be. I have that many moles of C2H6. But remember, I want to convert that using what I know here. For every 2 moles of C2H6, I could create 4 moles of CO2. Well, what if I had 6.6667 moles of C2H6? I don't know. But you know what I can do? I can multiply this to a conversion ratio factor, a ratio basically, between moles of C2H6 and moles of CO2 in this chemical reaction. How would that look? Well, I could write it like this. For every 2 moles of C2H6, I create 4 moles of CO2. Okay, great. I can multiply this to this. Or, instead of writing it like this order, you have to look at the alternate version, which is 4 moles of CO2 instead of being on the bottom can go on the top. And instead of 2 moles of C2H6 on the top, that can go on the bottom. Let's take a look at both versions. Which version am I going to go with? The answer is this version on the right. So I'm going to multiply this by this conversion factor times 4 moles of CO2 and 2 moles of C2H6 on the bottom. Okay, why did I choose this version? The reason why is because when I multiply this to this ratio or fraction or this conversion factor, the moles of C2H6 multiplied to this fraction where the moles of C2H6 occurs again on the bottom will ensure that they cancel out. Right now, if I stopped and I do all this computation here, computing 200 times 1 times 4 divided by 30 divided by 2, and I get a final answer. I don't know what it is. My final answer right now would be a number with the unit of moles of CO2. Okay, let's just pretend it's 10 moles of CO2. That's great. But remember, I want to see how much that weighs in its mass. If I stopped here, I only get, like, let's say, again, hypothetically, 10 moles of CO2. I would need to convert that into a mass. So you know what I need? I need what's called the molar mass of CO2. The how much 1 mole of CO2 would actually weigh. Does that mean I have to use the periodic table again? Well, normally, yeah, you'd have to look up CO, well, CO2, so you'd have to take that weight and multiply it to 2 and so forth. Okay, well, guess what? I cut you some slack on this worksheet. I gave it to you. Once in a while, the textbook or CK12 or whatever you're using to teach you chemistry will give you the molar mass of something that might be important for you to use. Well, right here, I got it. The molar mass of CO2 is 44.01 grams over mole. Okay, let me erase this so I have a cleaner workspace to continue working, to helping you to understand this. Okay, let's sidebar this. What does this translate to? So that translates to this. 1 mole of CO2 weighs 44.01 grams of CO2. But remember, I have to look at another version of that to choose between. So instead of having, let's rewrite this into another ratio, only the positions of 44.01 grams and that 1 mole switch. So that 1 mole of CO2 will go on the top, and the 44.01 grams of CO2 will go on the bottom. The question is, which version do I use to multiply to this guy? Let's choose, let's see, the answer is this version. 44.01 grams of CO2. Underneath will be 1 mole of CO2. Hopefully you understand the logic by now. The reason why I picked this is because the moles of CO2 is on the bottom. That was what my Unfinished answer is in so far. It's in moles of CO2, but I want to cancel out that unit. So I have to multiply it to the molar mass of CO2 in such a way where the moles of CO2, the units, occur again on the bottom. That ensures that I can do this. The moles of CO2 times a fraction where the moles of CO2 again occurs on the bottom. That enables me to cancel out the moles of CO2. So now, when I do this huge calculation with all these numbers, the unit that's left over with my final answer will be in grams of CO2. And that is exactly what I wanted and I set up for. That's what the question is asking for the mass of CO2. Okay, let's go ahead and put this. If you've been doing these videos in order, congratulations. This is the last problem that you're working on right now. So let's do this. It's 200 times all the top numbers of the fraction first. 200.0 times 1 times 4 times 44.01. Let's put that in one entry in the calculator. 200.0 times 1, that top 1, times 4 times 44.01. Okay, whatever that calculator spits out, whatever the calculator spits out for this, I take that number and divide it by 30, then I divide it by 2, divide it by 1. But you know what? I can just type in all of that in this same one entry in my calculator. So let's continue. What did I just say? I'm going to divide it by 30, so I'm going to put divided by 30 in the calculator. Next one is to divide it by 2, so I'm going to put divided by 2, and I'm going to put divided by 1. Press enter to get the final answer. I got about 586.8. 586.8 grams of CO2. That is the final answer. So basically what this says is for every 200 grams, or if you started with 200 grams of C2H6 and you converted it to moles of C2H6, see how much that is, and then you convert the moles of C2H6 to moles of CO2, and then however moles of CO2 you have, you're going to convert that to how much it should weigh. That's how much you should get back in CO2 by mass, 586.8 grams. By the way, this version of this rough draft of the solutions guide, by the way, might be a little bit different. It says 584.9. I think your key that I gave you the link to, it says 585. This is still all in the same ballpark, so they're all good. They're all good values. 586.8, 584.9, or 585, they're all good. As long as this number isn't like astronomically different, like that's 1,000, you got 1,000, or you got 1,200, you got 2, then you're not in the right ballpark. You're not even close. You got the wrong answer, okay? This number, by the way, the reason why that happened was because, do you remember back in C2H6, these calculations, I did a lot of rounding. Instead, like, remember on that 12, and the periodic table is actually 12.01. All that stuff when I was doing rounding results in a slight variation in the number. Only very slightly, but that's still the right answer. Good job.